things people have asked is, do you necessarily have to use slope-intercept form, or do you have to use standard form to put these things to graph? It's totally what you feel comfortable with. If you want to use slope-intercept form and then do your rough scaling with it, go for it. If you'd rather use and move it and manipulate it to set up a point slope form, go for it. If that's what you're more comfortable with. Either one is going to be just fine. It's just a matter of how you set your scaling to make it work. Okay? Now, me, I see those both in slope-intercept for that first one, and I would just kind of say, all right, well, that's pretty quick. I can make that scale rather easily because I've done it 18,000 times with this style of problem. So now I go up to 3, I go down 3 over 1, down 3 over 1, and between those would just be a dotted line. Okay? And then you start asking your questions. Now, as you ask the question on here, did that go through the origin, we would say, no. So we want to use the origin as our, what we call, test point. Come on. Remember, this test point is because the line splits the xy coordinate plane into two separate, what are called half planes. One half of the one side of the line is true, the other side of the line is going to be false. We don't have to pick the origin. It just so happens that multiplying and adding zeros is usually pretty easy for most of us. I was just not calling out anybody. Just think about it yourselves. So is 0 smaller than 3? Yes. So you want to cover the truth. You always cover the truth. Okay? Then I do the same thing with the x minus 1, starting at the negative 1. Then I go up 1 over 1, up 1 over 1. And again, this one's dotted. Did it go through the origin? No. No. Is 0 bigger than negative 1? Yes. Yes. So it is true now on this side of the line. So your overlap is in that region there. Okay? Bless you.
Thank you.
Okay? Yeah. In the second one, it's forcing you to what we remember how I was calling it a first quadrant the other day? It's forcing us to be a first quadrant problem. The reason that's being called a first quadrant problem is because you have x and y values that are both greater than 0. But in this case, it really doesn't help us much because the third inequality deals with an x-intercept of negative 8. So I still want to draw in where that x-intercept is going to wind up being just so that I can see what direction things are going through. So I have a negative 8 here. I have a positive 4 here. And between them is dotted. Okay. And I know that the x is greater than 0 is this way, y is greater than 0 is this way. And then did this graph, the dotted line one, did it go through the origin? No. So what's 0 plus 0? Is that smaller than 8? Yes. So that means this one's moving this way, so your overlap is in this region. Okay? Is this becoming easier?
Yes. This is easier than the other problems we had.
The algebra stuff?
Well, the ones we had that were
Those can get a little messy there. But it's the same stuff.
Yeah.
Same stuff. Number 11, you should have made yourself a rectangle. Did you make a rectangle? Good. Did you want me to walk through that?
No.
Okay. Vertical line at negative 2. It's moving to the right. Vertical line at 5. It's moving to the left. Horizontal line at negative 1. Moving up. And horizontal line at 3. Moving down. So you wind up with this region in here. Ooh. That's shaded. And when you have horizontal and verticals, those are the really easy ordered pairs to deal with. We know that the x-coordinate there being vertical was 5 for both of them. It just so happens the y-coordinate would have been at, what is that? First one was at negative 2. The second one was at 3. This one is at 3 and negative 2. This one is at negative 2 and negative 2. -1. Sorry, it's -1. Sorry. As you go through like that. Okay. Obviously, I wasn't asking that you guys worry about getting your ordered pairs, but when you're dealing with horizontal and verticals, they're really easy to see. Okay. Then the last one we have, what is it, x plus y. This one has the largest intercepts we're going to get on this one are going to be at 8. Okay. So the largest intercepts at 8. Zero, 8, 8, 0. It does that. Did that go through the origin?
No.
No way, Jose. What's 0 plus 0?
0.
Is 0 smaller than 8?
Yes.
All right. Okay. Next one you've got, I'm just going to do the y is less than or equal to 4 first. What direction does that have to open?
Down.
Down. It ran into an ordered pair here, didn't it?
Yeah.
What are the x and y coordinates for that? 4, 4, very good. You know that the y coordinate here has to be 4. So we take this y value being 4 and we substitute it into here because those are the two equations that it runs into. That's the idea as we start to get to the ones that we're trying to figure out specific parameters to, they'll start to be a little bit cleaner. So just for example, I know this is be at 4 and 4. And then the last one, I'm going to manipulate a little bit. I know that it's the same thing as 2x is greater than y. But remember yesterday when I did those, I always put my y value first to put it in terms of slope-intercept form. I like to do that just because me. So then I get y is less than 2x. So that tells me that I have a slope of 2 and a y-intercept at 0. So if I know that this is, let's see, this is 4, here's 2, 1, 3. This is 4, here's 2, 1, and 3. See how I'm just scaling with what I have already there? It's kind of helpful to do that if you can. So I start at 0, up 2 over 1, up 2 over 1, 5, 6 over 1. I don't know if I'm getting here or not, but then this guy goes this way. And then that one went through the origin, so I'm not going to use 0, 0. So what point could I use that didn't go through the origin? I can use, well, it's kind of close though. Why not use one we know definitely?
4, 4.
Okay. It's the reason why I try to stay as far away from the lines as if possible. I don't know if it did go through there. I mean, it looks kind of close. I mean, I know it doesn't. It's 2, 1, whatever. So if we try that at 4, 4, is 4 smaller than 8?
Yes.
Yes. So it's true moving towards that 4, 4 value. Now, it also had an ordered pair there. I believe that was at what? X was 4, that means, I'm sorry, y was 4, so x was 2. See how we're starting to be able to bound a region? Is there a floor to this problem? This one continuously drops, doesn't it? So in your mind, I want you guys to start thinking that this problem opens up downward this way. There's no minimum value to that. There's no floor. There's nothing to stop it. Does that make sense? And there would be no maximum if it was opening upward. Does that make sense? There's no ceiling to it. There's no cap on it. Just a little FYI where things start to head towards when we start doing constraints over the next Thursday-ish and going from there. Not bad? It's scary when we start to figure these things out, isn't it? Which means we can start revisiting our good old-fashioned word problems from this. So let's revisit a few of these. I printed them so they have to write them. I eat whole mushrooms. That's how great it works I am. I You missing something yet?
I'm sorry. Are you saying you're not enjoying your time with us? Hi. There you have it.
Hey, I appreciate you worrying about your friends though. It means a lot. It's not like your sisters would never do that. That's nice. You must be the good one. I am. Yes, sir. No, we're gonna do this out. So, ladies and gentlemen, as we go through some of these things, a lot of times I understand that we have this grown innate aversion towards anything that has to do with words with math, and I really don't know why that is. The best of my knowledge is that a lot of times at the lowest levels, they skip over them because they don't want to try to explain it. But I don't know. I guess there's just an innate want to know just how to do something and want to replicate, as opposed to infer and try to figure out what certain things mean. And that's where you guys are going to kind of struggle a little bit in this class because I try to get you guys to think about what things mean, what specific values do for certain parts. These things are pretty cut and dry. The linear ones are pretty cut and dry, but as you get into quadratics, what does it mean to be a maximum? What values are you looking for? Can you cross the same time slot or different? There's a lot of little things that we have to learn about how to interpret what goes through. But in this case, we're talking about movie tickets. And if you read it, it says tickets to a local movie were sold at $3 for adults and $1.50 for students. 170 tickets were sold for a total of $480. How many adult tickets were sold? What is this question asking you to find? Number of adult tickets sold. So anytime I have this style of a problem, I'm automatically going to circle what it's asking me to find. A lot of times what you guys will do is you'll do everything great, but then you'll forget, what did it just ask me to do? Get that out of the way right away so that we know what to look for. Okay? Yeah, exactly. So then it talks about two different things. It talks about number of tickets and it talks about price. Everybody see that? It tells you two separate totals. When you have totals, what do you think those represent? Yeah. We know something has to add up to equal 170, and then something has to add up to equal 480. Okay? Everybody with me so far? Now, it talks about tickets. It talks about adult and student. Now, what I like to do is I like to use X's and Y's a lot of times just because when we get to some parameter stuff, it's easier to plot them, especially if you're talking about XY coordinate systems. But you want to know which one's which. So if I say adult is X and student is Y, that only took me, 10 seconds to write down? The reason that I do that is so that way when I'm working with the problem, I know which one's which. I know that one value represents something versus something else. Okay? So I know that when I go to figure everything out, I have to deal with adult. So I have to look at the value of X, not the value of Y. Not terrible? Okay. Now, the next part should be this one, since it's just linear, it should be relatively simple to figure out our equations. They're talking about the number of tickets that were sold and the price that how much money you made off of them. Do we know how many tickets of each were sold? No. But we know that there was some sort of a combination, right? Yes. When you're talking about the combination of things, what are you doing to those two things? Adding them. So we know that our total tickets would have to be X plus Y. That's really pretty easy, isn't it? Okay. Now, thinking about that first equation, that X value represents number of tickets for adults. The Y value represents the number of tickets for students. Well, in the second equation, They're talking about price. So what do you have to do with the prices and the tickets? What is it? 3x and? Or $1.50 times the y, right? Because you're dealing with the price. $3 per ticket plus $1.50 per ticket. Okay. Remember, it's not that the math is going to be difficult, it's how do you extract the information within all the words. And that's where you guys will have a tendency to struggle a little bit. So I want to make sure that you see a few of these today, and especially as we get going into, I don't know if we'll see one yet, but I know we won't start one on Thursday. We might start one, we might start our first one on Friday as we get into this, okay? So, we have a system of equations. You know a bunch of different ways to get rid of and eliminate things. What do you want to eliminate first? Or substitute? What do you want to do here? X. Want to get rid of x? So what do you have to do? Divide by 3. You can, but what do you want to do?
Subtract y from the top equation so you can substitute it.
Okay, so that means what do you want to do to the top equation to be able to subtract all that through? Okay. But if I subtract, because if I subtract y already here, I still have 2 variables. We want to eliminate one first. What do you want to do? Okay. Yeah. If I multiply that top one by 3, then I can get rid of the x. If I multiply that top one by $1.50, then I can subtract out the y. Yes, sir. Remember I talked about this. I don't like to multiply by negatives. The reason being is that I know that where you guys make mistakes is that you'll forget that the negative went to all 3 pieces. You'll hit 2 out of the 3 of them. You'll forget the third one. The reason why I multiply by just the positive value is so that way when I rewrite, I get 3x plus 3y is 510, I think. So now, when I go to split up my problem, then I subtract all 3. You can do it. I'm not going to say you can't, but I know as doing this for a while, that's one of the mistakes that most students make. So that's why I just try to model not doing that. Okay? So what I'm doing there is, I split it into 3 separate math problems of subtraction. So we get through that. We get, what was that? $1.50 subtract 3 gives you a negative $1.50. And then 480 subtract 510 gives you a negative 30. Bless you. And then when you divide that out, I do believe you get 20. Sound right? Okay. Now, what does that 20 represent? Number of student tickets, correct? So if I had number of student tickets was 20, how many adult tickets were there? And then also it could have asked you how much money did something make? How much money did they make off of students? How much money was brought in by adults? See, you can interpret every little piece of that just ever so slightly. Okay? Not bad, was it? Okay. Read the next one. And I got that 150 because I just substituted back in the 20. Now, the next one, you have a computer club. They have a budget of $90 for a pizza party. The club can get large pizzas for $10 and cases of soda for $3.50. The club would like to buy at least 5 large pizzas and at least 3 cases of soda. Write a system of equations and blah, 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 blah. And then we'll figure out, can you buy 6 and 4? So, now the other day, Michael, you were asking me this one about inequality things. This is kind of the first one that I wanted to get into because it's very straightforward. When they talk about budget, do you guys know what it means to have a budget? Yes, sir.
You can't spend over X amount.
Correct. So the budget here is $90. Can I spend $90?
Yes.
Can I spend $91?
No.
Can I spend $89.75?
Yes.
So that means that the top end that I can spend is 90, so representing that would have to be some sort of an inequality. I cannot spend more than 90, so I have to spend less than or equal to $90. Right, see that? Now, I think in the problem here it talked about, it told you what to use for X and Y. I think it said X was pizza and Y was pop.
Yes.
Okay. So right away, within the budget deals with dollars. How much money are pizzas? And how much money is pop? So that means we have $10 per pizza plus $3.50 per case of pop. Are you with me so far? Okay. It then said that you wanted to buy at least 5 pizzas. Can you buy less than 5?
Yes.
No. Can you buy more than 5?
Yes.
Yes. So pizzas, the bare minimum amount of pizzas you can buy is 5. At least. Oh, sorry. I said that backwards. Thank you. I did that first after you think I would remember. You want to buy the bare minimum you're going to buy is 5, but you can buy more than 5. Same thing with pop. It said you wanted to buy, the least amount you wanted to buy was what, 3? That's a straight parameter problem, isn't it?
Yeah.
Okay. This is allowing us to set this thing up to figure out how is this going to graph itself through. So we graph it just like we have done to figure out parameters. Let me split the page. Now, in this case, you guys will notice that you've got your x and y intercepts. My x and y intercepts for the first inequality, where the x-intercept is at what, 9? And the other one is at some decimal-ish thing? 25.7-ish? Okay. So this case is a little weird. Oh, let me ask you. Can we have negative pizzas? No. Can I have negative pops?
No.
This is a first quadrant problem. Okay? This has to be within the first quadrant because nothing can go negative. All right? So I don't have to draw anything else. Now, like I said earlier, we have an x-intercept. The x-intercept was pretty easy. It was at 9. And then our y-intercept was a little bit weird. We said it was, what, 25-ish? I'm just going to write 25-ish. I know it's a crazy decimal. This case is kind of weird because it gives you weird decimals for some of the intercepts. But the essence of the problem is good because it's helping us to create some specific boundary area. Right? Now, between those two, I just create a solid line because we had a less than or equal to $90 because we could spend up to and including. Did that line go through the origin?
No.
No. So what's 0 plus 0?
0.
Is that, excuse me, is that smaller than 90?
Yeah.
So it's shading inward. So far, so good? All right. Now, x is greater than or equal to 5, which means you want us to buy at least 5 pizzas or more. Now, if I do that, 9's here, so 5's about halfway-ish. Maybe like that. Here's 5, 0. And which way does that go?
Right.
Correct. Now here, it ran into the first budget equation, didn't it? So basically it's saying that if I buy 5 pizzas, how much money have I spent? I've spent $50. How many cases of pop can I buy then if I buy 5 pizzas? What I'm doing is I'm substituting it into the system of equations to figure out the missing value. Yes, sir. 25-ish, because it was the y-intercept was 90 divided by 3.5.
I guess.
I guesstimate it's 25.6-ish or something. Right. So my ordered pair here is at 5, and what I'm doing is I'm taking 10. Oh, it's supposed to be a Y here. When you do this style, guys, when you're trying to figure out where things intersect one another, you're going to disregard the symbols of the inequalities when you're doing the algebra for the intersections. Treat it just like any other system of equation. Now, if you do that, you wind up with 3.5y is 40. And I think you get a crummy decimal here, don't you? 11.5-ish? Okay. And remember, the reason why I'm going with these crummy decimals for right now is just to show you guys the steps in which we're getting towards. Just by figuring out intersection points.
You want exact numbers.
It's close enough for right now. As we get into section 3.4 and stuff after the quiz, the numbers where they intercept become a lot cleaner. And those problems are designed to do it a little bit better. This is still a good problem to get you the idea of we're still solving a word problem with equations, and we're doing it visually. Okay. And then the last parameter we had to put in was what? Y was greater than or equal to 3. So if I do that, let's just say it goes here. So I know that this ordered pair is how much? 5, 3, very good. So that ordered pair would be at 5, 3. This one would be at something, comma, 3. And the reason I have to do what I'd have to do there is figure out, well, 10x plus 3.5 times 3 is 90. Okay. We do that, we get 10x plus, what was it, 1050, I believe? $7.95? We're okay with that? Which gives us this region. Okay? It gives us that region. Now, I'm going to blow that region up a little bit so you can see it better on the whiteboard. So this was what? 5, 3. 7.95, comma 3. And this was 5, comma 25-ish. Oh, I'm sorry. I was thinking of the intercept. Thank you. It's so precise. Okay. So the possible region for which pizzas and pops can occur is somewhere in this triangle to get your bang for your buck, if you will. So the question said, well, first of all, this means that if I buy 5 pizzas, I can buy 3 cases of pop. If I buy 7.95 pizzas, I can get 3 cases of pop. So I can get, I don't think the pizza guys would say, I don't know how to take out 5% of your pizza.
Will I eat it on the way there?
He could. So, but as you go from there. Now, the question that this asked was, could you buy, what was it, 7? Can you buy 6 pizzas and 4 cases of pop? Yes. Why?
Because it falls in that region.
Exactly right. Exactly right. It falls within that feasibility region. This feasibility region means that anything that lands within this value is in play. It works. So the idea of it being 6 and 4 is about here. That means happy people because there's pizza. I mean, who doesn't like pizza? I can't remember the last time I actually had delivered pizza. Because it's always quicker to go pick it up. Oh, yeah. I don't order delivery. I haven't ordered delivery in.
We're just released. We don't want to buy.
Right, it's never warm. Because I know if they say it'll be ready in 25 minutes, I'll leave my house at 18 and it'll be piping hot when I'm coming home. Yes, sir. Okay. Does that make sense with this one, guys? Not too terrible, is it? All you're doing is extrapolating some info and setting up parameters. I haven't done anything talking. Jeez, would you like a hurry to leave or something? Now, one of the other things that we do that I like to do in here is we get the wall of autographs, and we haven't had any yet this year. Your sister would know. Your sister knows. So you get to autograph the wall, and you get to be our first one. Yeah. You get to be our first person on the wall. Aren't you excited? I don't sense that you're excited. Oh, you said in the way so we can see your name.
Go up and down.
I can hear it. Wait, hold on. Watch this. I got an idea. This could be fun.